guys. Today we are gonna talk about membrane distillation process. Before starting anything, how many of you are familiar with distillation process in general? Have you ever heard about it before? Okay, never mind. Distillation process is a process, as you can see in this illustration, to separate components of a liquid mixture and producing a pure water out of it. Here in this container, we have hot water, and since water is hot, the temperature is something between 60 Celsius to less than 100. And since we have hot water here, the water evaporates, and water vapor passes along a tube which is connected to a condenser. And condenser is much colder than vapor, so the water drops is produced here, and they condense in this section, and we let water drip into a container and collect it here. So we have pure water here, and this is a process of distillation, and we want to figure out that what possible use we can have for distillation process. Distillation process traditionally is used to desalination of water and just producing pure water out of brackish water or brine. Do you know what is brackish water or brine? Brine is highly salted water, and brackish water is slightly salted water. So for seawater, for making pure water out of seawater, we use generally distillation process as an alternative. So we want to go over membrane distillation process. Do you have any idea what's possible difference between membrane distillation process and the conventional distillation process? We use membrane to separate the condenser part with the vapor. And we have some objective to do that. I'm going to explain it later. But as you may see in this illustration, we have this hot water in this container. It's container of hot brine here, and it's heated by a coal. So we have hot water passing along this tube. We have 2 cells here, cell number 1. In cell number 1, water passes through this canal, and it is exactly connected with cell number 2 in this shape. And I just separate 2 cells to show you what is going on between them. The exact configuration is like this. So have this in mind and just separate 2 cells. In cell number 2, we have cold water passing along this canal. So this is cold water. Temperature of this cold water is something like 20 Celsius, and water here is between 60 Celsius to 80 Celsius. So since we have hot water here, we have water vapor just mixing with hot water here. When water just reaches here, water vapor passes through the membrane located exactly between 2 cells. Membrane location is here. We have a membrane here. Membrane is very porous, and also a property that it has is hydrophobic. Hydrophobic means that it is permeable to water vapor, but impermeable to water. And water can pass through it because membrane is made of material which doesn't let water pass across it. and it never gets wetted. It's like Teflon. Have you ever seen like Teflon or some materials that never get wetted in water? Membrane is something like that, mainly made of PVDA, polyvinyl divinyl chloride, or PP polypropylene, or Teflon, PTFE, polytetrafluoroethylene. So just water vapor passes through it, and since we have cold water passing through these canals, the vapor condenses in the stream of cold water. And we have just water vapor condensed there, and they passes through these pipes along with the distillate that were already in the pipes. So it is recycled here and goes back to the distillate container. So we have pure water here, and we made it out of brackish water. And one advantage of membrane distillate water over traditional distillation process is that we have membrane here which doesn't allow any material pass through it. So when we have some matters like natural and volatile organic matters in the wastewater, which we usually have like our samples here, like we have some VOC mixed with brine in our samples. The membrane just get them stuck there and doesn't let the organic matters pass through it. So we have in conventional methods, maybe it's water vapor. 2 minutes?
You got only 30 seconds left.
Okay. We have some VOC may pass along with the water vapor here because they are volatile, but in membrane they get stuck, and we have only pure water in our container. So for future work, maybe in future presentation, just tell you what methods we can figure out to have a very optimal process. Any questions?